Okay, good morning, everybody. We're still waiting for a few more people to come on in. Sorry about the early hour for those of you on the West Coast. Um, Trying to avoid conflicts, but I think we're going to end up pushing it to a later hour next time. Um, but we'll sort of see how this works out. It looks like everybody's still showing up, so that's good. Um, we're going to do a round of introductions once everybody gets here, but right now, I'm going to sort of go over the agenda, which is that we will be taking a look at a quick summary of what's being worked on right now, and then sort of go over the design requirements, sort of what needs to get done and what our short-term goal is, which is sort of by the end of, I guess, this coming month, September. We want to have a theoretically production deployable proof of concept. That's a pretty aggressive goal. I'm not entirely sure, and it's going to be broken. I mean, it's not going to be a test net, it's going to be a broken net. The goal is to solve most of the little integration problems and the operation problems and reach a point where people can really run Peggy, because, how should I put it? A lot of bridges are meant to be deployed once and they become quite complicated. But particularly for the Cosmos ecosystem, I want to make sure that Peggy is easily deployable by everyone. Now, obviously, once IBC is out and matures, that's a bit less of a major concern. But for now, I feel that it's important to ensure that multiple zones can easily deploy Peggy, even if the eventual long-term sort of situation I see is that the ideal host for Peggy would be the Cosmos zone with the highest native staking token value, because that allows the highest amount of value stored in the bridge given our design, which would be the hub, obviously. So yeah, I think we've got most people here right now. If anybody wants to do introductions, feel free to just go ahead and introduce yourself real quick. Keep in mind, meeting is being recorded and will be posted to YouTube shortly after we finish this.
I just wanted to say hi. This is Deborah Simpier. I'm the CEO of Althea.
Hi, everyone. Say a quick hello. It's Michael O'Rourke, CEO of Pocket Network, and we're looking into doing some Ethereum stuff, so super keen on hearing the progress on this. Thanks, guys.
This is Dean Tribble of Agoric. We're doing DeFi Legos that connect through IBC to all the rest of Cosmos. And very interested in connecting to Althea. Or Peggy.
Hey, this is Aki. I just think Peggy is one of the sort of more important initiatives right now, and putting a bunch of energy to trying to make sure it moves as quickly as possible.
Hi there, Alberto Hauregui of Pocket Network, and writer of Dis Weekly. So I just want to listen and learn more and cover this in my infra focused newsletter.
Cool. I think that's everybody. So yeah, here we have sort of the checklist that I wanted to try and go over today. And what I'm going to do is that I'm going to go into a bit more detail about the structure, technically, of the implementation and what exactly is being worked on than I did last week. If you're interested in more high-level cooperation stuff, there are going to be other meeting. There's another meeting about that Wednesday that I'm sure you'll find on our Twitter or whatever, where we sort of make the argument for why Peggy, why the hub, and those sorts of high-level questions. But right now, we're going to dig right into the tech and the immediate goals, and the real details of getting this done. So, I've mentioned this before, but a key part of the design for Peggy is what we call the validator daemon. And what that does is that it is a daemon process that runs on the validator. And that, let's see, so we got tests. So what it does is that it manages the off-chain work of Ethereum signing, submitting, and monitoring Ethereum. So what I'm working on right now is specifically around synchronizing signing between the three different components of Peggy. Those components being the relayer, those components being the validator daemon, the Cosmos SDK library, Gaia itself, and then the Ethereum contract. And this is rather tedious. This is sort of tedious signature work. But it's important to get to sort of the next steps where we're implementing a lot of these flows. So the first flow that I am working on, and currently how should I put it? So this entire flow to create a validator set, update the validator state on Ethereum, and then submit transaction batches and send funds back from Cosmos to Ethereum, as well as to receive funds from Ethereum to Cosmos, that's all implemented on the Solidity side up in the Solidity folder here. And you can run that fairly easily. What I am working on now is integrating the rest of that with, is integrating this flow in the contract with Cosmos SDK and our validator daemon / relayer library, which is written in Rust. And right now I'm working on, so if we head over here, don't I have contact somewhere? Oh no, I must have overwritten that window. So anyways, contact is a Rust library for talking to the RPC, for talking to the Cosmos SDK RPC light client. And what I've got so far here is flows for validator set requests. So to take you through the process here, this needs to go up one level. Okay, so to take you through the process here, the validator daemon process running on the validator sets an Ethereum address for that validator. And they do this by sending message set ETH address signed with the validator's funds holding key on Cosmos. And then that sets an ETH address in the store. Anybody can send this message, including people who aren't validators, but we only care about the validators. And the handler validates that they signed the ETH address with their Cosmos key. And then somebody submits message valset request. And this is the first part of updating the validator set on Ethereum. Somebody says, hey, I want to update the validator set on Ethereum. They send message valset request, which takes a snapshot of the validator set at the current block, at whatever block the message gets included in. So now that it is in a block, so now that we have a block defined and a validator set defined, all of the validator daemons query this using valset request. Yeah, that is a very bad naming. Anyways, so they request what the latest validator set is that they need to sign over. They verify it. They sign over it. They don't really need to verify it since it is part of the consensus state in the chain. So their daemons sign over it with Ethereum. They submit this signature back to the chain. And now, once again, this is in the store. It's just a message. Anybody can query it. It has its own little endpoint. And now, finally, somebody can grab all of these signatures, submit them to the Ethereum contract, and boom, you have updated the validator set on Ethereum. And this flow is really just replicated. The process for moving transactions from Cosmos to Ethereum is the same concept, except it includes a state machine for handling the Peggy transaction pool, transactions that are waiting to go across the bridge. For the deposit process, the oracle is once again the same, except you observe Ethereum, and then you send a signed message saying, I saw this thing on Ethereum. And once you get enough signatures for that, well, in this case, you don't need Ethereum signatures for this part of the process, but once more than 66% of the validators have said, hey, I saw an event on Ethereum, you mint the coins. You mint the representation of the coins that have come across the bridge. So this is the really sort of foundational signing logic and infrastructure, and it's kind of tedious, but it's something that needs to happen because currently, so if we go over, oh no, I am in the right folder already. So if I go to the module folder and then X Peggy, let's see, where is this again? I sent it to Jahan just yesterday. So essentially we need to take this, yeah, here. So this is a message valset confirm. If we come, yeah, so message valset confirm is what you use to send a confirmed signature over a validator set. And if we go to the definition of this, which I don't have because I'm not in the right folder in, I guess it's in messages, isn't it? Yeah. So we need a serialization definition for this, and then we need to replicate that serialization over in the contact library so that we can get it all signed and test this flow. So that's sort of the very in the weeds, detailed interpretation of what am I working on right now. You can find you can find contact on GitHub altheanet/contact. Obviously the Peggy repo is uploaded to Obviously the Peggy repo is on the Cosmos/Peggy GitHub, and I keep it up to date with pretty much every day. I try and push once a day, at least. So let's see, to sort of bring this all into the big picture. So right now we have to go from a very fine focus and kind of zoom out some. My goal is to get the validator set update process working, get it tested some. And then after that, to go and get the very basics of the transaction batch submission working, and the very basics of the oracle, because all of those are just different message types. They use different parts of the same logic. And at that point, it should be viable to deploy what I want to call a broken net to indicate that, yes, we do expect it to pretty much break. That will have the capability to move a single type of ERC20 hard-coded at contract deployment time back and forth. And I want to do that roughly by the end of this coming month because I believe that's a feasible design target. Helps us find a lot of things. Helps us find a lot of problems. It's obviously not exceptionally usable in the production sense because if you have to hard-code a single type of ERC20 token, you're not really, it's not super useful, but it solves a lot of problems, namely around the fact that if you want to accept arbitrary tokens, you've got to do significantly more store logic. You also can't decide what the token is named because Ethereum addresses are slightly longer than the maximum name length for a Cosmos token, which presents you with the wonderful problem of either you truncate and hope you don't collide, you make a smaller hash and hope you don't collide, or you accept the name of the ERC20 token and hope nobody tries name collision there. I think the last is completely untenable. The first one is what we probably want to do, just straight up truncation of the name. But yeah, the point is to get something that is theoretically deployable to production and usable and something that the public community can sort of get in on and try out. But isn't really the final deal because I sort of want to take care of the the sort of foundational practical problems that keep you from actually running the code first, and get worried about theoretical slashing conditions, etc., as we get closer to production. Speaking of theoretical slashing conditions, there's a pretty good discussion in the Peggy Cosmos channel in Discord about exactly about situations where consensus is broken and what that would mean for the bridge. And this is sort of an interesting topic because when you break consensus, let's say you have a validator that's 33% of the chain, and they suddenly leave or they fail. Well, the chain halts. And this normally isn't the end of the world because you can just get everybody together and restart the chain. It is bad, but your money doesn't disappear. On the other hand, with Peggy, in its current design, if you were to have a validator with 33% of the stake to just simply disappear and never show up again, you would actually lose the money in the bridge because it would remain locked. There wouldn't be enough multi-sig signers to get 66%. And update the validator set. So some sort of very minimalistic like client functionality may be required in the contract in order to break out of that condition. But I would prefer to avoid working on those sorts of edge cases until we have something that generally moves funds at all. It's easier to fix edge cases like that when you have something complete than to sit around and ponder how you might fix them in a more generalized structure. So I think that's most of what I wanted to go. Let me go find my agenda. So signing synchronization, relayer design. So I should cover this again. So there's going to be 2 Rust binaries that come with Peggy. One of them will be the validator daemon, which the validators run, and will handle a lot of this transaction batch logic and submission logic and observing the Ethereum blockchain. And the other will be a very simple traditional relayer that is designed to take the actual risk and perform the task of paying for batches to be submitted to Ethereum. And this is something of a, how should I put it? Since we're using transaction batches, the cost of submitting a single batch, if it is efficient, is going to be, like an ETH or something big because you're submitting 100, 200 transactions at once. So it is fairly costly. So there's going to be something of a market there for people who are willing to pay that money. And I want to make sure, obviously you recover the amount in fees, but the fees are paid in the ERC20 that you are relaying the batch for. So for example, if you have a batch of DAI transactions, you're going to get fees in DAI, and you're going to have to sell those to cover your costs in ETH. And I want a relayer that does that automatically to hopefully avoid, I'm sure most of us have heard of the maker situation that happened earlier this year, where there was nobody running auction bots because they were not robust enough, and various problems, and there were actually attacks designed to take down the auction bot as part of all of that. But I would like to design a very robust relayer as part of the default distribution of Peggy to help reduce that problem and ensure that there is somebody always running a relayer willing to submit transaction batches, and we don't end up in some sort of transaction batch fee stealing situation, which is another edge case to worry about. But in this case, it's a little easier to handle because you just have to actually publicly release a good relayer and make sure it's easy to run. So I think that's everything that needs to be mentioned on my agenda. I'm not really sure how long these meetings should go in general. An hour is probably maybe a little bit too long if we don't have a lot of conversations to have, but I don't know. So anyways, I am open for any questions, and yes, so I am happy to take questions, but more general questions along like the larger plan of development for Peggy, funding for Peggy, deployment of Peggy to the hub, development of Peggy and funding for that sort of stuff. We'll be having another meeting Wednesday, which I don't quite remember the time of. So if you will forgive me and check my Twitter, which will actually have the correct time and details for the Wednesday meeting. Oh, Deborah, do you have it?
It's 11 a.m. Pacific time.
Okay. And that would be Wednesday, this coming Wednesday.
And it's a YouTube live event, and you can find out all the details on Twitter.
Yeah, and that's gonna have Thank you.
Alberta.
Yeah, that's gonna have more of the like general details of like what does it mean to deploy Peggy on the hub, et cetera, et cetera, et cetera. Right now, I'm interested in comments on the technical design questions about flows or security risks, and of course, if anybody is interested in contributing to any of this, it's not exceptionally complicated. It's just sort of tedious to implement. So feel free to ask whatever you need to get involved.
Us Pacific Coast folks, maybe you're not quite awake yet.
Well, maybe. I get the feeling that a lot of people are laying in bed with this meeting on their phones or something like that, which is something that I will
I have
admit
no
to having
idea what
done.
you're talking about. This is Dean. So I have a question. So the two sides of connecting to it for a sovereign Cosmos zone, whatever, is obviously connect over IBC to whatever chain is running it, or run our own. What are the trade-offs?
Okay. Yes, this is an excellent question. So the trade-offs are that your validators are going to have to do a little bit more work to run Peggy. They need to have an Ethereum node that they trust, because we solve a lot of the design security problems that more complicated bridges have by simply saying that the validators are going to run their own daemon, which watches their own Ethereum node, and this can be a light client, that will give them, sort of trustable RPC responses. And this solves a lot of the trust problems, but it is somewhat of a burden on the validators, who will have to make sure that they have a high quality Ethereum node in addition to a high quality validator. And this is problematic because Ethereum nodes suck, like, incredibly badly. If you've never run an Ethereum node in production and you've just kind of casually run one, you have no idea how bad they are. They give the wrong answers with wrong block heights. They stop synchronizing. They restart. They halt. They do weird crashes. They consume your disk space. They consume all your RAM in strange ways, because somebody will send a transaction which will cause it to eat all of your RAM and crash. So it really is, even if you're running an Ethereum Lite client, it is a non-trivial amount of trouble to manage running Peggy yourself in that sense, because your validators will have to do that. And in a bad case where your validators do not do their required maintenance and do not keep their ETH node working, you could theoretically lose access to funds on the bridge. So let's say that nobody produces a validator set update in too long, and more than 33% of the validator set has changed out, then that will result in an unrecoverable bridge. Now, there can be slashing conditions to keep you from getting to that state in the first place, and we do plan for those. But there's a certain amount of risk, and if your validator set is on its toes, the risk is not very high. If your validator set is very casual or doesn't really know what they're doing with an Ethereum node, risk may be somewhat higher. Then there's part two, and that is that the bridge really is just a multi-sig for the validators. And if you don't trust your validators, or how should I put it? And if your validators have less at stake than there are funds in the bridge, you are in trouble, because they can just run off with the funds in the bridge, and that's an issue. There's also theoretically some issues around what happens if you have very large validators with a very large portion of delegated funds, because you're slashing them because that changes the ratios. So let's say, for example, you have a validator with 33%, but only 1% of it is their own stake, and the other 32% is delegated to them. what they have at stake is actually significantly less than the value of the funds in the bridge, even though technically the total amount of stake they control is greater than the value of the funds in the bridge. So you get, as a note, the only thing a validator with 33% of the stake could do is hold the bridge hostage. They couldn't actually move the funds. You need 66% for that, just like you need it to take over the chain. So these are sort of the complexities and risks that you could mitigate by going over IBC. And especially if you have a really solid validator set with a really large amount of staked value, you can end up in a situation where these aren't big restrictions for you. They'll still be something of a problem for the validators running Peggy.
The going over the bridge, that assumes that the zone at the other end has, it has all the same issues, right? So if you're going over IBC to the Cosmos hub, and that's where Peggy is run, there's still the same issue of validators there having little at stake in comparison to what they have staked, right?
Yeah, that's still something of an issue, and I think it can be mostly ameliorated by with like one or two sort of like client style features for specific slashing conditions and bridge rescue. Because even though the hub does have validators with, a significant amount delegated compared to their stake, it doesn't actually have that many of them. Nobody has 33% stake, and it's as long as nobody. So as long as no one validator has more than 33%, and you're getting into like Tendermint failure territory, Peggy will always work so long as Tendermint itself doesn't have a failure. The problem is that Peggy is currently, and I believe we can fix this, is currently less recoverable after a Tendermint failure than a normal chain would be. But if you can avoid a Tendermint failure, you're safe. So the more diverse the validator set is, the safer the bridge is, and this is one of the reasons why we spent as much time as we did trying to make sure that the Ethereum contract could handle a full-sized validator set, because all of these problems are amplified with smaller peg zones.
Got it. Thank you.
Cool. Thanks, Michael. Cool. Okay, so we're coming up.
Justin, quick question.
Yeah.
Morning. Quick question, Tarek here. I think back to Dean's point, Dean mentioned in the Telegram, what thoughts and plans we have for security and audit testing for Peggy. Did you cover what type of when you think of auditing and possibly testing some of these assumptions, what we might look at in the future? Are there any of those that would speak to the validator set security, or is that something that currently, at least from where we've talked, we've already covered?
So as far as testing security assumptions, I would really like to have enough funds to do a incentivized testnet that's reasonably sizable. At the same time, I would like to get the code to a point where it is more written and we know its restrictions before we really start planning in too much detail where or how we want to audit and in what detail. Because, obviously the Ethereum contract needs some level of auditing, but it's fairly straightforward. It's just a multisig for the validators. The game theory assumptions, they're probably going to require some inspection, but our goal was to minimize the edge cases as much as possible. So I think that by the end of our implementation, we'll have a few edge cases, a few mitigation strategies, and we'll want to run an incentivized testnet and probably bring in some experts to review key hotspots before it really gets deployed to large-scale production. But, fundamentally, I would rather vulnerabilities that are in front of me than vulnerabilities that are unknown. So I'm always hesitant to add too many fancy cases, because you're tempted to say, oh, look, if we do this fancy light client signing this way, we can solve this case, or if we do this fancy thing, we can solve this. I would really rather have a known security issue that's well defined than implement a lot of complicated code in Solidity or a lot of complicated game theory over on the Cosmos side and have it blow up in my face in unexpected ways. So I think that's a sort of a short summary in that we're probably going to want to run an incentivized testnet before anybody puts $1 million in this and have some level of an audit. At the same time, I am going to prioritize simple solutions with known problems. With if you have a validator with more than 33%, that's going to be an issue. I would much rather just have that in plain text than to have a scenario where things go wrong. That is unexpected, I should say.
Got it. Thanks.
Cool. So do we have any other questions? And Michael, I believe you're a little bit coming in towards the end here. But this will be on YouTube in just an hour or so, or whenever YouTube finishes processing the video, which is normally not as fast as I would like. But my complaints aside, it will be available.
Thank you.
So, yeah, we're coming up on the half hour. Well, we're a little past the half hour, and I think that's everything, unless somebody else has another question. Cool. Thank you all very much for coming, and I look forward to talking to you 2 weeks from now, which would be...
Just in question. Whoa.
Sure.
You're talking to us on Wednesday. You're talking to us on Wednesday too.
Oh,
but
yes.
Before this, are we going to have a recording of this we can share with folks across Cosmos?
Yes.
Awesome.
I'm just about to go over and hit the stop recording button over in OBS.
Awesome.
Okay, cool. Thank you, everybody, for attending.